So we did a lot of shopping, we learned a lot, and we finally want to shoot. And that's what we're doing tonight. So shooting happens outside. And so we are now outside on my terrace where I usually shoot. So what do I have here? I have, from my perspective, the first step, and usually you take your stuff apart more or less, except you have an observatory. But usually I leave the mount as much as possible together, just put the tripod together, throw it like that in my car. If it doesn't fit like that, you can obviously detach the mount from the tripod. So why do I have two mounts here? Because I want to show you today how to proceed with two different mounts. One is I would call a beginner mount, very easy to build together, very easy to use. And we're doing the shooting with the ASIAir. And the other mount here is definitely an advanced mount. Here we will use Nina, and so you see the differences. So when you put up these mounts initially, important is that they're steady, so I wouldn't go on a soaked lawn, but there also shouldn't be too much vibration. That's a little bit of issue with my wooden floor here, so I try not to trample around while it's actually shooting. And then what you also might observe, that both mounts look in exactly the same direction. And this direction is north. Because, as we already discussed, equatorial mounts have to be polar aligned. Now, is this exactly north? No, it isn't. How did I do that? I took my compass on my iPhone, just put it beside here, and just checked that it is approximately north. The exact polar alignment we do much later with the software. There was a time where you had a little polar alignment scope where you had to find Polaris, where you actually had to be able to see Polaris to be able to polar align. These times are gone. Today we do it with software, with Nina, with the ASIAir, and in both cases you can have them point wherever and they can polar align. If you're setting up your mounts on daylight, which is recommended because you need time, you don't want to lose any night time, so you start early. That when the night falls, you're ready to shoot. But when you actually build it up on daylight, it is absolutely crucial that the lens cap of your telescopes is still on, of all of them. Guide scopes, real telescope, whatever. Because only a little bit of sunlight, when it comes in directly, which might happen when you balance and so on, might destroy about everything you have. The camera, the telescope, and so on. So make sure that the lens caps are on. Also make sure that no dirt comes onto your lenses. And with that, let's build them up, and we start with the easy one. So here we have a Sevo AM5 mount. There's even a smaller, lighter one, the AM3. These are harmonic drive mounts. They do not need any counterweights up to a rather large amount of weight. They're very compact and they're very precise. We already discussed that. So I'll take now my telescope together with the camera and I just slide it on. I do it approximately in the middle, and you know what's the cool part? It does not have to be balanced. I couldn't care less. I just do it approximately, and that's it. It's on. So now I have exactly two cables which I have to plug in. This here is the cable for electricity. It goes in the saddle of the mount. Well, this cable here, obviously I also have to plug in. That's the energy cable. But mount-wise, there's just another one here, which is data, which goes from the mount to the computer, and also have in the saddle a place where to put it. Now in this case here, I will actually use a battery to power it. You hear it beeping, means it is ready. Powering on, waiting for connection. I don't know if you heard it. It actually talks to me. So from a cable point of view, there's no cable except the energy cable, which goes from this axis down to the mount. Nothing, which means there is no chance of entanglement practically. And that's great because if a cable entangles, it can, in the best case, rip out your USB cable and you don't have any data anymore and your night is ruined. In the worst case, if it cannot rip it out, it can actually do serious damage to your mount, to your camera, or wherever the cable was plugged in. So this mount is ready. Did you see how fast this goes? I can now practically wait until it's nighttime and I'm ready to shoot. I do not have a guide cam because that's integrated in the camera. I do not have a computer because that's integrated in the camera. And if you want to know more about such a system, I made a dedicated video how to put this together from when you buy it, and I put a link in the description below. With that, we go to the other mount, the Avalon M0. This is a very unique mount from the mechanism that it uses with bands going around. It's very precise. Also practically has no backlash at all. Means if it goes one way and then the other, it's practically precise again where it was. It's also very unique as it does not have a meridian flip. Means a regular mount like this here in the middle of the night, when it goes over the meridian, it has to flip around to go then in the other direction. This is kind of feared because of entanglement and other issues that can happen. And here it can just follow the object throughout the whole night. That's absolutely great. The disadvantage is to be precise, it needs to be balanced. And we will see what I mean. So now I proceed same way as I did here, and I will actually move OTC, the telescope, with camera on the back here. So we're taking this now, which is obviously much, much heavier than what we had before. Okay, make always absolutely sure that this is very good tightened, that this is really flat, because this is the only point where all of this is actually connected. If anything goes wrong, you lose a lot of money. What we also need here, because of all this weight, is some counterweight. We put this here on the bottom. Okay, so let's just look for a second what we have here. We have the telescope, we have behind it the camera, which is a Moravian camera, together with a filter wheel. Because this is a mono camera, so you need a filter wheel. This has actually 8 filters in it. Then we have here an electronic autofocuser. We also have this in the other mount. Now the things that were integrated there and which are separate here is on one side a computer. Here we have a Primalucha Lab Eagle 5 connected to the rig. That's also very unique at the Avalon rigs, that everything that's below here acts actually as a counterweight to the telescope. So you need less counterweight here, which is cool. And then below here we have actually the guiding system. Given that this is 700mm, I actually used here a 400mm guide scope, which I still had. It's a little bit an overreach, but again, I anyway need the weight to counterweight this one, so I could use a little bit something bigger. And then we have a guide cam at the back. Now I think the biggest difference is, and you might already see that ton of cable. Because here everything is separate, so everything has to be connected by cable. And given some part is below, some part is above, there goes a lot of cables between these two axes, which can lead to entanglement. And also we obviously have to attach now a lot of cable, which is much easier there. Everything which has cables is on top. We just plug it in and that's it. But here the computer is actually below. If I add this here, which has a lot of different elements, all these elements have now to be connected to the computer. So we have here a USB cable for the camera. We have here electricity for the camera. We have here a USB connection which goes to the environmental sensor on top of it. This one actually checks the temperature of the dew heater and compares it with the dew point, so it can actually measure the air humidity. And that's, for example, something which is done here way more precise than with ASIAir. We have here an energy cable which goes to the electronic autofocuser. We have here a cable which connects the dew heater. The other one, the dew heater for the guide scope, is already connected. This is both below. Then we also need the USB cable to the electronic autofocuser. And with that, I think we're done. Now, as I mentioned here, I have to look at the balancing. So what I do, I open here the clutch, that this can freely rotate. And so now I play with it until it stays around stable. So you see, I knew about where I had to put it, and this is almost balanced. And then I put the clutch on again. Now here, from an electricity point of view, I have a main connection to the Eagle, and the Eagle then distributes the power to all the rest of the rig. And here I use actually a huge power brick to supply energy to everything. So now it's connected. I have to press now the power button of the Eagle, and then this whole system also starts up. Now you might be wondering, could I also run this system here with a battery? And the answer is yes, absolutely. But I think it's kind of obvious that if I have a choice and I would go to a dark side, I would much rather take this tiny little thing with me than this monster. Because while this has absolutely its advantages, but the chance that something goes wrong, something gets forgotten at home, is just so much bigger than with this here, where you cannot really do a lot of wrong things. So now what sometimes confuses some people is that these systems do not have any eyepiece. It's impossible to look with your eye through it. So what you obviously need to work with them is a computer. Now, when we first talk about this system here, I will run it with my iPad. The ASIAir connects through Wi-Fi, and it's a dedicated Wi-Fi network produced by the ASIAir with my iPad. So I don't have any issues at all. I do not need my home Wi-Fi. I can just go somewhere, select the Wi-Fi of the ASIAir, press enter device, and here we are, it's connected. And I will show you afterwards a little bit more how this ASIAir or the iPad platform looks like. But with it, I can do everything that I need. I can autofocus the system thanks to the electronic autofocuser. I can polar align by plate solving. I've obviously go-to possibilities, so I can tell the telescope to slew to any objects that I want. I can guide with it so that it follows it accurately, and I can program it that it does so and so many exposures of so and so length throughout the night. I can even live stack with it, that I can see the progress of the stacking live on the screen, which is absolutely amazing. And you can also see that I very easily can even now slew the telescope to wherever I want. So all of that with just a fingertip. And if I'm ready now, I could obviously also take already calibration frames if I have not done that yet. But when it comes to darks or bias frames, you better do them not in the bright sunlight, because there might still be a light leak. And then you have actually the worst results than without the calibration frames. So I would recommend to you to take any calibration frames which require dark at night or inside in the basement and not at bright sunlight. But if you do not have a flat panel, that would be now the moment, especially because the sky is nice and blue, to turn the telescope upwards, put a white t-shirt over it, and then you could actually do your flats. So if you ask me, what do I recommend for a beginner, then it's exactly that. It's an easy to connect rig with only a few parts, which is easy to assemble, where you cannot do a lot of mistakes, And with the ASIAir, you have also the easiest software to use it. It doesn't offer all the possibilities that Nina does, but you do not need that at the start. So now let's talk about this one here. How do I talk to the Eagle? Eagle is in principle nothing else than a Windows computer. While the Eagle is built like a tank and has a lot of additional functionalities, like a little lens which checks the sky quality, like built-in GPS, and so on and so on. But it's still a Windows computer. But in a more basic rig, you could also use a mini computer like a Mealy Quieter, which works exactly the same. Now, theoretically, it has an HDMI port, you could put a screen somewhere, you could connect through Bluetooth a keyboard and a mouse. So you have this option, but obviously that's not very convenient. There's also even more cables that can lead to entanglement. And if it's winter, if it's not that t-shirty weather like today, you will have to stay outside, which is not that comfy. That's why how it's usually done, you have a notebook, it can be a Windows or a Mac, and through the Microsoft Remote Desktop, you connect right to this computer. I will show you afterwards on the computer a little bit more about Nina. But in general, what can do this rig, what this rig cannot do? First of all, we have here different hardware. For example, a Moravian camera, we have a Primalucha Lab focuser. These are parts which the ASIAir will not support. So if you want to use anything not SIVO except of the mount. With the mount you can use whatever you want practically with the ASIAir, but if you want to use another camera, another filter wheel, another focuser, you're actually bound to go to Nina. And Nina is more complicated, granted, than the ASIAir, but it's also manageable, and I have a tutorial about Nina, which is called Nina as easy as 1, 2, 3, and I will leave a link in the description below if you're interested in Nina. So you might ask, so why would I even do that? For example, with the filter wheel, I have 8 filters in there. With SIVO, the maximum filters you can put into a filter wheel is 7. There are some reasons that you actually want to go this route. And the other point obviously is that if you want to use Nina, you have to use a mini computer or an Eagle or something like that. So why would you want to use Nina if it's more complicated? Well, it offers you a lot more possibilities, especially when it comes to how you program the rig throughout the night. You can also transfer the pictures right from Nina to a solution called Light Bucket, where people can follow you what you're shooting throughout the night. It has an absolutely great flat assistant, which automatically takes the right length for doing the flats. So while you can do enough with an ASIAir to make great pictures, if you really want to max it out and use all the possibilities, then Nina is the way to go. So when it now gets dark, and with dark I mean the astronomical dark, then we would do the plate solving and the polar alignment, execute this script that we wrote either for the ASIAir or for Nina, and then it can actually shoot throughout the night automatically. Please be aware that you only let your rig outside and go to sleep if you're 100% sure that there's no rain throughout this night. If there's only the slightest possibility that it could cloud up and start to rain, I would not take the risk and I would stay up. So we're now looking at the preparation on the computer. First with the ASIAir, then with Nina. And then we will take a time jump and actually look how both systems run while the shooting is going on. So here we are now on my iPad, and what you see is the entry screen for the ASIAir. Here I had already to select the ASIAir Wi-Fi, then I can click enter device, and then we're actually in. And that's how it looks like. And the first thing I want to do is I want to make a 3-second exposure. That happened now, it has to be processed, loaded, and now we see the picture. You even see here a satellite trail. So the first thing I want to do now is to polar align. For that I click now on the PA, get in here, and now it actually starts. It will now take picture, plate solve it, that's what's happening at the moment. Then it actually moves the scope, takes another picture, plate solves it again, and then it does it with a third picture. And based on these 3 pictures, it can actually know exactly how the scope is pointing to and how it has to be corrected. So now here you can actually see it. It figured out that we have to go down and we have to go right. So now I actually manually make this correction on my scope. Then I can actually say it should refresh it, and then it will show what I have to change now. And I will do that as long until I'm very close. Now we go to focus, and here you can actually see that it takes now individual exposures with different focuser settings, and so it can create a curve, and based on this curve it knows then exactly where the ideal focus point is. And so here the red dot is now the perfect focus points where the stars are the smallest. So now I enter the go-to command that the scope slews to M71, what it's doing at the moment. It will also plate solve when it's there and autocorrect if it is not 100% where it should be. So this is now a first picture of M71. You see it very faint in the middle. And so we are now ready, and we will look later with a nebula how the shoot is going. Now while the small rig with the ASIAir is already shooting, I can show you here on my remote desktop what's happening on the big rig. So as stated before, here we enter in the Eagle dashboard. Here in principle you see the Eagle with all its ports. So for example, if I want to activate the camera and the mount, I do it here, and now they get energy. Before they had none. Also I have to turn this here on, this is the focuser. I also see now here the darkness. We're in a Bortle 6 at the present time. It will still get darker. It's a little bit cloudy, so that also impacts it. I know what the current temperature is. It's 11.9 degrees Celsius. We have a humidity of 85.2%. That gives us a dew point of 9.5 Celsius, which means we're not much above the dew point. When we get to the dew point, then the dew heater is really needed, otherwise it will cloud up. So the next thing I have to do, I have to connect the mount. And you see how much more complex this all is. All of that I didn't have to do in the ASIAir. This was just done. Sorry, so here I have to say now it's on home position. So it's aligned now. Okay, and with that I can start Nina. And that is how Nina looks like. I have now to connect everything, the camera. I have to tell it that it starts cooling. Then the filter wheel, the focuser, the mount obviously, eventually also the guider. I can also enter here the weather sensors of the Eagle. And you see again, I have now here the temperature, the dew point, the humidity. This is all going right in here too, also the sky quality. And I can even add the switches so that I can now actually in the script exactly say when, for example, it should cut off the energy to the camera at the end of the shooting and so on. I kind of go here in the imaging portion, and I can, as before with the ASIAir, state that I want to have a picture, for example, 5 seconds, luminance, and let's see. And here is the picture, still very nicely focused. I have now all the same functionalities, and I will not bore you with that I had before in ASIAir. I have a 3-point polar alignment. I have autofocus function. But what really differs Nina from the ASIAir is here the sequencer. What you see here and what looks extremely complex is a whole script over the whole night. I can add as many targets as I want, and it will auto-slew to the targets to the time that I give it to. I can actually let myself be notified on my cell phone when there's an emergency, when, for example, it cannot focus anymore, anything else happens. I can say it should center again when it drifted away from the main target. I can say that it should autofocus after an increase in the star size, and so on. And then I have tons of possibilities when it comes to shooting. And so for mono shooting, this is really great. But again, it is so much more complex than the ASIAir. And while I actually started right with Nina, and it's possible, if you like it a little bit easier, definitely the ASIAir is the more relaxed start into astrophotography. Now fast forward, and the shoot is actually running. As you can see, this here is the sequencer and where it is at the moment. It will shoot at the moment 10 green pictures, which are 30-second long. Here you see the guiding, and here the last picture that was taken. So this sequence can now run throughout the whole night. When we go back here to the Eagle dashboard, you see now that we're now Bortle 5. So it's now completely dark. Also the clouds have gone away. And another thing I want to show you here is now the light bucket, which I mentioned. So here you see people from all over the world who at this present time are shooting, and they're shooting various things along the sky. And what you see here, that's me shooting the Veil Nebula. And so if I'm interested, I can now actually go here on monitor, and here I see everything what's going on. I see my RMS, so the guiding score. It's between about 0.35 to 0.6. That's absolutely great. I have the HFR of the stars. You see that it actually changed here after 10. These were the red pictures, these are the green, and so depending on color, stars can have a different size, so that's normal. So the great part here is that light bucket runs over the internet, so wherever I am, I can on my cell phone check if everything's fine, if everything's running. And I would see if suddenly the whole screen is clouded up, or if suddenly it's not shooting anymore, so that I can run back to my rig and solve the problem. At the same time, at my ASIAir and at my SIBO rig, that's how it looks. So we're here still in this live stacking mode, so the picture gets better and better. At the moment it has already stacked 12 pictures. Also here we have a guiding at the moment of an RMS of 0.57, so that's also very good. You see now here also the stars that it guides with. And so the good part is that this picture you see here is not the only output, but actually I get all the individual pictures and I can afterwards stack them together. But this is obviously for public outreach or for just being excited while you shoot. It's amazing that you can follow your picture develop, picture at a time. So I really like that. In the morning, practically for sure, your rig will have caught some dew. That's normal. And the rig can manage that. But just dry it off a bit. And when you take it inside, don't put it right away into a cupboard, but leave it outside so that it can really dry up from the dew. And what we then have is a lot of data. Hundreds of pictures probably. All the light frames, the calibration frames, and then comes the part where we're not dependent on the weather anymore, but what we can do in front of our computer, and we can stack it and process it so that we get to a final picture. And that's what we look at in the next 2 parts of this tutorial. Until then, I wish you, as here presently, clear skies.